Welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, in our final episode of the year, we're looking back on the outage trends we've seen in 2024, as well as covering recent outage incidents at OpenAI and Meta. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Let's start with our look back at the outage trends of the year. Here's Mike on the major themes he's noticed in 2024.
So if I take the two biggest groups that we see in terms of outages, they are ISPs and CSP outages themselves. And I sort of put those together, they make up the majority of the outages we actually observe over the period of time. Now, the biggest sort of shift I've seen is the ratio of the ISPs to the CSPs. ISPs have the biggest footprint in terms of the infrastructure they have in place, obviously because they're covering the globe, whereas the cloud providers, the CSP, sort of, they're concentrating these areas, although they are starting to go into the network side of things. So traditionally, we'll see more of ISP outages, and that hasn't changed this year. But what has changed is that ratio. If we actually look at that from the 2022 perspective, we had 89 to 11, with 89 being the ISPs, into 11 being the CSPs there. Once you moved into 2023, that actually shifted to 83-17. So if then we actually compare that now to where we were in 2024, we've sort of seen this ratio shift again. So it's actually gone up another 10%, where we're now looking at around 73% for the ISPs to 27% for the CSP. So we sort of see this shift, and this is increasing there. So despite this sort of shift, I said the ISPs still remain the prominent ones, but we're starting to see the greater increase in the CSPs, and obviously that ratio is growing, sort of more outages occurring there.
How much of an impact do you think the explosion in cloud-based AI services has had on the increase in the proportion of cloud outages?
So a lot of SaaS applications are increasingly incorporating the AI capabilities. So there straight away, there's a rising demand for cloud resources due to these integrations. Then if we actually consider sort of the AI-driven marketing tools, content creation platforms, they're all shifting workloads into the clouds because they sort of need these compute resources. And then we have various companies that are adding generative AI features to enhance their existing applications. With this trend, we're starting to see this greater reliance or this greater demand for these cloud resources themselves, because this will need to run these workloads. Then on top of that, effectively, we have this situation where we're talking about data sovereignty and that. So this trend started to create these hybrid workloads. They require more cloud resources to do the efficient operation themselves. And with this increased demand requires more infrastructure and more resources. So we have these demands. The cloud providers have to sort of change. They have to increase their footprint. They're looking for this more distributed architecture or continue to move this distributed architecture, because we're having these integrations, we have more interactions, and therefore sort of more dependencies linking everything together.
Cloud usage is still continuing to increase, but it's now a mature technology. Would you have expected reliability improvements to have kept outage levels stable, even as usage has grown?
Fundamentally, I actually think the cloud provider outages have remained reasonably stable. And when I say that, I know we talked about the trend increasing, we're talking about this ratio getting bigger. But if we actually consider the footprints actually got bigger, so there's more interaction, we have more dependencies, then there's potentially sort of more areas to go wrong. So I say it's more proportional with the actual increase from there.
So overall, CSP outages are growing at a rate we'd expect given the expanded cloud usage. Mike shares more.
Then you also have to consider that we have maintenance that does occur. Because we're growing this infrastructure, we're looking at 24-hour systems, so we need at some point to take things down or to create outages, as it were, in these maintenance windows where we can do that. You can't make an omelette without breaking a few eggs. So we have seen on occasions this increase in the outage numbers, which we can attribute to a time of day, which you can attribute to either more infrastructure being put in place, because we've linked that to sort of scheduled developments around there. So say if I go back and look at everything overall, although they are increasing and the dependencies coming there, I would actually say they're sort of relatively stable in terms of the proportion.
While ISP outages continue to occur in greater numbers than CSP outages, they account for a smaller proportion of outages than they used to. We're also seeing signs of a significant shift in how these disruptions are managed. Tell us more about this, Mike.
If you actually look at how the cloud providers did previously, we sort of see this very localized impact because there was sort of a lot of software-driven architecture itself, so it can actually make changes and sort of kind of contain that. What we're starting to see with the ISP outages, and this accounts for sort of this reduction, or we're accounting out for the reduction there, is there, if you like, more localized or more contained. So we're impacting fewer regions when each one goes down. Now, we still have this situation where we're talking about outages do occur and we'll start to see those. But then if we think about this from a maintenance perspective or even from the scheduled work scenario, we actually started to see them sort of more contained. And what I mean by that is if we have an outage where we're upgrading a line card or we're making a change to an optical card in a particular system there, we have alternate paths where we can actually sort of switch things across to. So we can do a lot of that in software now. So we can actually make that change. So therefore, when we take that card out, it happens. We have these automatic failover processes where something goes down and we'll actually switch across. If you think about where we had the cable cuts in Africa, where we lost 3 of the systems there, the only reason we actually sort of had some disruption, or one of the main reasons to have disruptions to the Microsoft environment, was specifically because they lost an optical card at that moment in time. So they'd actually lost their redundancy, but alternatively, they could actually sort of switched around there. But fundamentally, because then we have sort of these systems in place, what we're actually able to do then is to sort of improve that ability to contain it. In the past, where we might have taken down an interface on one side of the world, the other end of that interface, and I know I'm talking in very simple terms here, was connected to it. So I had this domino effect. So one outage would lean onto another outage, would lean onto another outage. Whereas now where we're sort of dealing with these types of these automatic failovers, this software-defined operational, not only are they understanding to a larger degree the impact they're going to have by sort of taking something down, but also they're able to work around it and contain that outage into more area. So subsequently, what we then see is that where we'd see an outage occurring on one particular zone, that isn't then sort of reflected on the area there. So the numbers themselves might be dropping, and then they are all contained in one area there. What I will say, if we don't talk about that redundancy and sort of switching across there, we still do see these outages. We'll sort of see them occurring where they do impact various services there. But what we're also starting to see in those instances, because of distributed architecture, what we're starting to see is more functional failure in the application itself. And what I mean by that is we can get to the front door, we can get to the service itself, we can get to the CDN. What we can't do is execute on it. We can't pull back part of information. We can't actually make some sort of change query in the back end or something like that.
On December 11th, OpenAI experienced an outage that people might suspect was created by overwhelming demand for the company's new Sora generative video service. Here's Mike to explain what actually happened.
On December 11th, they experienced this outage. It started around 11:15 p.m. UTC, and it affected the login and API services particularly. All these services, including the Sora video generation model, were rendered unavailable till around 1 a.m. UTC. What we actually saw when we started to look through this from our test, we actually saw a series of 403 errors. If I look at what a 403 error is, it comes up as sort of forbidden. It actually occurs after the authentication process. What it means is that I can't actually get to that service. It's not necessarily that it's an authentication problem itself. It's an error sort of generated from that. But what it actually tells me is that it's not willing to process that response. I don't know how to get there. I couldn't get there. But all in all, if I put those together, what it actually kind of tells us or points to is there's a back-end problem. Now, I say that because if you actually look to the front end, there was no network issues that were detected. So we're getting again into that front door situation where we could get to the service, but we actually couldn't then make a query. We couldn't pull something in the back end, which is that functional failure I'm sort of talking about. According to OpenAI, the outage is actually caused by a new telemetry service deployment, and it's actually overwhelmed the Kubernetes control plane. And what this then led to was this cascading system failure. So when we were talking about those network issues of the past where we'd have one system took down another system, similar type of thing happened here. So we're dealing with this load situation, which actually sort of rendered the Kubernetes control plane unresponsive. This failure at the Kubernetes control plane level, it affected the node operations in these large clusters. So the way that OpenAI and ChatGPT, the sort of the Sora services work, they also have these clusters to do these large computing processes because we're starting to do quite a lot in the back end there. Now, because this then has this cascading effect, we had these widespread access issues.
OpenAI's very detailed incident report states that DNS caching masked the severity of this problem because many users were using cached records for a period. What effect did this have, Mike?
It actually didn't mask the problem itself, but what it actually meant was it didn't show up in the testing. So in fact, it only started to show up as a rollout was taking place. Remember, we had this sort of cascading impact. We needed to go across there. So as the rollout was near completion, there's stuff built up from there. So the key point to that is that DNS itself wasn't the cause of the issue, and it wasn't a mitigating service. It was just a way of actually functioning. but this increased load overwhelmed the control plane and actually then broke that bit DNS-based service discovery. As a result of that, the services didn't know how to contact one another. The DNS caching provided temporary relief, but there were stale and sort of unusable records. And this is why it didn't show up in the testing. After about 20 minutes, the cached records began to expire. And then the services started to fail as they sort of depended on a real-time DNS resolution. Now, the timing of the issue's emergence kind of delayed the awareness, i.e. the actual rollout was sort of in full flight at that moment in time. They'd sort of gone too far to stop it and pull it back. So before the full extent of the problem had been recognized, they'd actually gone too far into the process. The reason I say that is typically we think about these situations. Obviously, this is a large company. They have a lot of instrumentation in place. They can understand what's going on. They knew they were doing the change around from there. And we think about this and we talk about this a lot, where the monitoring a system and sort of reverting that change is actually reasonably straightforward. Okay, we got here, we see the problem, and we do a rollback. We see it all the time. And we actually talk about these situations where we'll see these outages occur in London buses in sets of threes, where we start to make a change, we roll it back, which we've done the fix, and then we implement it again. What occurred in this place was because we'd actually got sort of so far into this situation, even OpenAI detected the issue quite early on. And we noticed because their status page, they sort of made announcements around from there. But the actual fix at that point required removing this problematic service. They needed to sort of turn it off and clean the stuff back there. In order to do that, they needed to access the Kubernetes control plane so they could actually implement the fix there. But because of this load on the Kubernetes, servers actually prevent themselves getting access to control plane.
So what lessons can be taken from this incident?
So obviously, testing takes place. But what you can't do is necessarily sort of understand every possible scenario it's going to take place. There's no way they could have actually rolled this out. They tested it in a test cluster environment. And like I said, they sort of saw this. It essentially wasn't run long enough potentially to sort of see this. But it's more the load they couldn't have actually seen as it started to go across there. But what they wouldn't be able to do that is, and they did this, is understand that complete service delivery chain. So know what's happening there. And the point of that is once I've actually understood how things are made up and what's going to go there, so if something does go wrong, then I actually know the impact of the issue and I know what I need to do to resolve that. We've had situations in the past where there's a change to a BGP table has actually sort of taken down the access systems to the data centers. So people couldn't actually get into the door. Their cards wouldn't work because the whole network was down. So they couldn't remote into it because the system was down and they physically couldn't get into it. So they had to get people there. But what you actually do is that if you understand the nature, you'll understand those dependencies and you can actually sort of do things to reduce the impact in the future. What do I do in this situation? If this occurs, what do we actually do? So where you're not necessarily always going to be able to prevent an issue, what you can do is reduce that impact you're always going to have on the end users.
Also on December 11th, Meta experienced a global outage that affected services including Facebook and Instagram for several hours. What happened here, Mike?
The outage started around 5:55 p.m. UTC, and it manifests itself as internal server errors and timeouts. Now, again, straight away, this kind of gives us a clue to where we're actually looking at. So it tells us this is a back-end service. So we're looking at a server error. Again, this is an error. This is a 500 error or 500 type error that tells us that we've made connection, we've established that connectivity, and then what we're going to do is to get some sort of response coming back from wherever we're calling that information from. So we saw that, we see a timeout, and the two combining together tells we're looking at a back-end server issue. We can confirm that by we actually looked at the network connectivity coming into sort of Meta's front-end servers. Now, this remained unaffected during the outage itself. What we did observe was a decrease in loading of web application components. And what that is the number of components on a particular page. So when you actually do a page load, we've talked about this before, there's a number of components that actually get loaded onto that. So, typically, let's say we might be looking at 67. If we actually sort of drop that number down to 2, then it can indicate a couple of things. It could indicate that the page has been sort of optimized and therefore it's sort of running faster. But then you actually say, well, we're missing components, not loading a full page. Or it could indicate, as it did in this case, there's some sort of issue. Now, typically, if I'm looking at a decrease, well, actually see I'm only loading a couple of components. What I would actually see is that page load time drop. But here we saw the page load times increase. And again, this ties in with that timeout situation and why we're able to say this looks like a back-end service issue because we're actually getting to the system and it's waiting to complete as opposed to sort of just completely failing around there. The other thing we actually sort of saw across here was this castellation effect, so that up and down. And this kind of sort of shows intermittent impact. So this was a global impact. All regions appeared affected, but not always at the same time. So we saw these intermittent ones. So sometimes some servers were there, and then this is where we see that castellation effect. And also if we looked at the availability itself, we could actually sort of see, sometimes some of the regions were getting through, some of them weren't. And what this actually meant then from a usage perspective is that the users sort of experienced or delayed or unreachable features, like sometimes they couldn't post a message, but it did impact both the desktop and the mobile application itself. Again, so there we're not looking at some sort of commonality. If we're looking at a particular provider from the mobile situation, or we're looking at from a particular region from a network perspective, again, we're saying, okay, this looks like it's sitting on the application. This is in the network itself. And that kind of gives us these features, what we're looking for.
When an outage affects multiple services at the same company, does that help narrow down the list of likely causes?
It can certainly point to like an aggregating perspective. And we had a Meta outage earlier in the year where there was an issue with the authentication system. So again, what you find out at that point is there's a common authentication system right across the environment there. Or it could be something like where we had an issue impacting multiple services from a provider that have to have their headquarters out of a data center in Portland, but it impacts all services around there. So it does start to point to a single aggregating point, which starts to get in there. The fact then that we're looking at all the Meta services in this case, kind of straight away we're going, it's unlikely to be hitting multiple network providers to actually do that. So unless I'm actually coming into Meta's front end or Meta's network, and again, it's within their environment itself, I'm really suspect I'm actually looking at an application issue itself. But you also then have to sort of think or consider around multiple services from different companies. Multiple people all sort of go onto the main cloud providers. If you think about the cloud providers we have out there, we could all be hosting on AWS, for example. All my services are sort of hosted on there. So again, I'm looking for commonality. Or I could be using a single CDN provider. But what you have to do in all of these is be very wary of attribution. So we have had instances where it looks like it's impacting all these services that are hosted on a particular cloud provider. When you got into it, it's actually a downstream transit provider. And what it is impacting one region. It's just because of the path they're taking to, because they've had direct internet access, or they've had these sort of express paths, and they've all gone through this common path there. What you're looking to do is actually to try and understand where is the common point from it, and not jump to conclusion and say, all these services have to be hosted on this particular cloud provider, therefore that must be the problem. You actually need to break that down and look at each of the signals and sort of put them all together to see what's happening. Once I do that, I also then know what steps to take. Is it impacting all these applications? Is it all these services provider? Do I have an alternate application I can use that performs the same function? Or are we taking like the case where we had that transit provider issue for the network where it looks like it was on the cloud provider? If I go to a VPN, therefore I can actually make myself appear in a different network. So understand the characteristics of the outage or the issue or the degradation allows me to understand what steps I need to take to mitigate it, to work around it, and to get the service back up. In some instances, it may well be do nothing is what we need to do. If we're relying on all these services from this particular provider and they've identified this issue, but they said it's going to be up within an hour, or we've identified it, we're rolling it back, or whatever happens to be, it might just be we're going to sit down there for an hour, we're going to get a cup of coffee, or we're going to finish the day early, or whatever it is. But the key to this is if I know what's going on, therefore I can actually make the right decision of what action I need to take.
And that's our show. For more on 2024 outage trends and lessons learned from some of the most notable outages of the year, join us on January the 21st for ThousandEyes' upcoming Top Outages of 2024 webinar. We've included the registration link in the description so you can check it out and sign up. We look forward to seeing you there. And please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it, and not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, have a great holiday season, and we'll see you in the new year.